Hello, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. We have House Robber today. It has like so many variants, so we're up to the fourth variant for House Robber. If I remember correctly, it's usually always DP, but let's have a look. Um, so there are a bunch of houses. Yeah, actually let's see what we have first. So we have we have k, which is an int, and then we have some number. We have a list of numbers, which is 100k, and they're all ints, and k could be like around half of nums, but yeah, let's see. So you're given several consecutive houses, and they all have money. So I think that's what nums is. Like, is the amount of money in there. There's also a robber, but he refuses to steal from adjacent homes. Yeah, okay, so it's just what they had before. So the capacity of the robber is the maximum amount of money he steals from one house of all the houses he robs. Right, and wait. So the capacity is the maximum amount of money he steals from one house. Huh. Right. Okay. So you're given an integer array nums. So that's how much money in each of the house. So the ith house has nums I dollars. You're also given an integer k. So the minimum number of houses the robber will steal from. It is always possible to steal at least k houses. Yeah. So maybe it is not DP then, but let's look at the so return the minimum capacity of the robber to steal at least k houses. Right. So the capacity is so let's say the robber steals like from like 2 and 5. The capacity will be 5. Like, it will be the house with the maximum number in it. But they can't be adjacent. Actually it could still be DP, but yeah, let's just have a look. Yeah, so in this case, yeah, two ways to rob at least two houses. Yeah, so you can do 2 and 5. You can do 3 and 9. But then, you can also do 2 and 9. Yeah, but like, of course, this one is the lowest, so we want to go with that. What about this one? So this one we have a lot more ways. So we have to be mindful that k could also be k could also like for this case, because k is 2, right? We are actually forced to, like, we don't have that many choices. But let's say if k is 1, like there are like a lot more choices, right? Or like, let's say like when this is longer, like when there are more houses and k is still 2, like there are just like so many more ways you can steal. So the way which leads to minimum capacity is to rob the house at index 0 and 4. So we want to return so max nums 0, nums 4. Yeah, because if we rob like this, it'll definitely be the be the quickest. Like the capacity will be the least. So yeah, honestly, this could be DP. Or wait, yeah, again, maybe you can think about like turning the the optimization problem into a decision problem as well. So what if we turn the problem into something like whether a robber of capacity maybe like capacity 4 can rob two houses here. So what we can do is so because we can only rob houses we can only rob houses with like less than 4 amount of money. So that means we can only rob these two houses. And like one more observation to make is it is always better to, like, let's say you have like multiple choices, right? It is always better to rob the house on the most like far left, unless you can't. Actually, is that true? Let's think about it. Yeah, it's definitely true. So like, so let's say we have like more stuff. Um, it's like because we are not actually like counting the actual amount of money that we rob. We are not optimizing that. We are trying to optimize, like we're trying to minimize like the house with the most money actually. So that's very contrary to what a robber should do. But yeah, so let's say we have a 5 here. Well, if there's a 5 here, it doesn't matter which one we pick, right? But if we have like a 4 here, well, like remember our decision problem is like we have a robber with a capacity of 4, right? So we can rob all of them, and of course it's better to rob this, because well, if you rob this, you cannot rob this as well because these are adjacent. Yeah, so I think if we turn it into a decision problem, we can solve this in n log n time. So yeah, let's get coding. Um, so of course, for any binary search problem, um, we need a. We don't need spelling mistakes though. We need um a Boolean function. Yeah, and like one more thing to notice is that if a robber of capacity 4 works, a robber of capacity 5 will also work. So it is monotonic. That's why like we can use binary search. But well, we always need a like is valid function like for the binary search. We'll pass this for now. So it's possible we'll put a value, so capacity of the robber, which is going to be an int. Yeah, and then now we do the binary search. So what are the ranges of numbers? Yeah, so it starts with 1. Well, the robber can the robber with a capacity of 10 to the power of 9 can definitely work. And if all of them are 1, uh the robber can rob like can have a capacity of 1. So like if the whole nums array is 1. So therefore our left bound is going to be 1. Our right bound is going to be well 10 to the power of 9, which is 1e9. Yeah. So we also need the mean capacity. We just set it as something random. Yeah, let's just do our. It doesn't really matter what we set at the beginning. Because like we're guaranteed to find the solution within this range. So while again, just very normal binary search. So if it is possible for capacity m, well, we want to set minimum capacity to be m. Otherwise, and not otherwise. If it is possible, where do we want to search? We want to search on the left, right? So if 5 is possible, like let's say for this case, if 5 is possible, we want to search 4, right? Well, or like we want to search from 1 to 4. So that means we want to move our right bound to n minus 1. Otherwise, we want to search on the right half. So we want to shift the left bound up that way, and then at the end we can just return minimum capacity. Oops. Capacity. Yeah, and now we just have to write this function. So yeah, so we should have the like the index of the house, and then so for do we want to do 4? I think we just do like while index is less than like length of nums. And then we want houses robbed. Rob count maybe. Yeah, rob count. So that's the number of houses we can rob. So if we can rob the place, so if nums index is less or equal to capacity, that means our current robber can rob that house, right? So what we can do is well, we do have to increase the index by 2 because we can't rob the adjacent house, so we can't rob the direct next house. But then that means like we rob one house as well. Otherwise, so that means we can't actually rob the house. Well, we just want to increase the index by 1, and yeah, and then at the end we can just return row count. Should be larger or equal to k. If I didn't mess up anything, yeah, it should be the correct answer. And yeah, so that's binary search, turning into a decision problem and doing binary search, which has been a theme for, I think, like three to 4 days. But yeah, thanks for watching. I'll see you tomorrow. Bye.